Please yell if you can't hear me. But so yeah, I'm Riyad. I'm from Cubist. I'm the CEO and one of the co-founders there. I'm also faculty at Carnegie Mellon. I'm sort of work on cryptography, stuff like this. Staking and restaking are really close to my heart. When I was a PhD student, I worked with my advisor on some of the cryptographic primitives that have ended up in the BLS signature spec. We actually wrote the spec together, and it was all very fun, and a lot of politics at IETF and all kinds of fun stuff that I very much recommend that you try out. But so we've been thinking a lot at Cubist about how to manage keys safely and about in general, how to prevent mishaps. And so I have this term anti-slashing on the screen. I'm going to talk more about that later. I think maybe think of it as slightly stronger than just slashing protection. So the question really here is, okay, how do I build a safe and secure validator? And let me define both. Secure means that an attacker can't make my validator do what I don't want it to do, and presumably that includes something like slashing. Safe means that I can't accidentally do it myself. Like even if I fat finger my Kubernetes configuration, whatever it might be, I want to make sure that my validator will remain correct, which is to say that it won't get slashed to first order. And so, the idea here is, and it seems like an obvious, simple idea. Make sure that the keys can only be used to sign the right messages. Well, duh, okay? Because like your validator's interface to the world is the keys. If it never signs a wrong message, it can't get slashed. But let's make this a little stronger. Let's make it, what I really want here is an abstraction that says, this is a key. There is exactly one such key, and it lives in the sky somewhere, so I can't accidentally have a split brain. And that key will just refuse to sign any message that isn't compatible with the policy, where presumably the policy includes no slashing. And so this is the system that we've built. We're backed by hardware security modules. We use Secure Enclave. We build in AWS, so this is Nitro Enclaves, it's a really beautiful system. And so the idea is you have this secure hardware core that's able to give any kind of signature that you want with really high performance. And around that, we have a policy engine that lets us give exactly this abstraction. Your key will never behave in a way that is against policy, and there's simply no way to sort of work around, say, the anti-slashing policy. You can't accidentally instantiate two of them. You can't accidentally make a request that somehow ignores the anti-slashing policy. And then all of that is accessed via a really simple API. So this makes your key management easier and much safer. So I'm going to show you easy first. So this is an example of just like setting up a validator. So I'm going to generate a role. That role is going to, and by the way, this is all through the API, but I'm using the command line because it makes my life easy. So I set up a role which is sort of a container for all of my permissions. I pre-generate some keys, and it outputs sort of the Lighthouse config. And then I generate a token, which is a permission to use those keys in sort of accordance with the config. And then I start this CubeSigner, we call it, which is a Web3 signer compatible interface that gives you access to exactly this sort of abstraction of a key that lives in the sky that will never sign the wrong thing. Okay, so that's like, this makes your life easy, but let's talk about safe, because somehow everyone's much more worried about that. So these are a few validators. These are on Holshki. I wish I could show you mainnet validators, but like, OPSEC reasons, I kind of don't want to, but sorry. But these live on Holshki, and they are, let's see if I can't make the video play. And so what we're doing here is, I'm going to do some validator maintenance. This is maybe going to look familiar. If you've recently looked at, say, what's gone on mainnet, about a month ago somebody got slashed because they had to move some validators from one data center to another, and in the process there was a mishap and there was a double signing. But we're going to do exactly that kind of thing, and I'm actually going to be pretty aggressive about it. So this QR code will take you to the beacon chain interface if you want to take a look. They're still running now. So I've got this machine. This machine is running my validators. You can see I've got I'm running Geth and Lighthouse. Good, okay, great. So, and then I'm also running the validator on the same machine, which, maybe not the best setup, but that's okay, it's just testnet. So here we go, we're signing, and this is what Cube3Signer looks like. It gives you sort of detailed information about what it's doing, and right now it's sort of happily signing along. And so this is the machine, it's up and running, but I want to do some maintenance on it. So what I'm going to do now is, eventually here, what we're going to do is we're basically just going to start another validator. We're not going to stop this one first, we're just going to start a new one. Yeah, well, that might seem a little risky, but again, the key lives in the sky, and it cannot sign a slashable message, and so I'm certain that I will not get slashed as a result. So I already have a machine running the beacon node and the execution node over here, and so now I'm going to do something even more aggressive. I'm going to delete the local anti-slashing database, which you can see I'm doing right now. Good, we don't need that. Yeah, that's just a pain. Good. And so now we're going to start Cube3Signer, and then we're going to start up the validator. So you'll see in a second here, okay, Cube3Signer's running, the validator's running, and it'll pop up, and you can see that indeed it is going to be signing for 4 keys. You can see indices 59, 62, 61, 60, which are exactly the ones that were there before, and the same ones that were running on the left here. So we've got now 2 validators that are simultaneously running. Usually a bad idea, but in this case, totally safe. And actually, just to be even more certain that I won't miss, I'm actually going to start another one. And same thing, anti-slashing database locally gets in the way. We're going to get rid of that. We don't need it. Good, slashing protection's gone. Locally, again, the key lives in the sky, and it can't sign a slashable message. So good. So now we've got our 3rd validator running. So now we have all 3 running on the screen here, which is pretty cool. And you can see, again, the indices 62, 60, 61, 59. And this is Cube3Signer. We're about to get some signatures. OK, so the whole thing is kind of started up and running. Good. So now we're ready to do some maintenance on our original, which I think is right now in the top right corner. But we'll move it over to the sort of main box on the left in a second here. Good. And so what we're going to do is, good, this is now on the left. We're shutting everything down. And then we're going to just like apt-get update, apt-get dist upgrade. Yeah, so that'll take a second. But in the meantime, let me tell you about this anti-slashing condition. So what does this mean? Why is it stronger than just slashing protection? The idea is it's a precisely defined concept that is like, we sort of talk about it in concurrency terms. We have a strict concurrency requirement on a history of all signatures generated by a key. And as long as we observe that strict concurrency requirement and we enforce the sort of consistency, life is good. So that we just saw, again, beacon chain flashed by. It was sort of just showing you things are still running. This is now like at 50x kind of catching up with the chain. So we're resyncing after a reboot. And now we're synced again. Great. So that means, OK, it's, now we're basically ready to start our validator again. What we're going to do here is, yeah, again, we're going to start Cube3Signer. And then, actually, let's, again, delete the local slashing database here. Just don't want it to cause any errors. Good, so that's gone. And now we can start the validator again. Good, and so, again, all 3 are running, but now I don't need the two that I was running in backup, so those are done. OK, good. So this idea that we can precisely define what it means to not slash means that we can actually prove that a system cannot be slashed. If we can meet this concurrency requirement and these requirements regarding the consistency with sort of the history of signing, that's enough. And so this idea we're sort of generalizing into work that we're doing with Eigenlayer and Babylon and others. We've announced last week the Secure Staking Alliance. We're thinking about exactly this kind of problem. How do you precisely define what it means for a validator to be secure? And how do you produce not only these technical definitions, but also community standards that will guide everyone towards safer staking and safer restaking? And that includes when I design an AVS, I want to make sure that my AVS is actually compatible with anti-slashing. Because I could come up with some crazy slashing condition that's not anti-slashable. Not all slashing conditions are anti-slashable. So we want to make sure that if you're designing an AVS, it's easy for you to say, I know for certain that this slashing condition is anti-slashable, and therefore I can give extremely strong technical guarantees about the likelihood that my operators will get slashed. And that is the way that we're going to get people to move into this space, that we're going to make restaking really something that people can be confident in. So this is the link to the Secure Staking Alliance webpage, and I'm Riyadh. I'm at Cubist. Thanks a lot for your time.